Here's another example of an inelastic collision. Okay, now in this one, unlike the previous example, the blocks are not sticking. What's happening is, if you look at the before picture, all in black, we have a 1 kg block moving to the right at 10 meters per second. It collides with a 2 kg block that's moving to the left at 4 meters per second. And after the collision, what we know is that the 2 kg is moving to the right at 5 meters per second, and the 1 kg, we're going to have to figure out the speed of the 1 kg block, the velocity of the 1 kg block. So once again, since it's an inelastic collision, okay, or rather, we do not know what kind of a collision it is. All we know is that the blocks are moving and no other information is given, so we cannot assume KEI equals KEF. So we will use PI equals PF. Okay, PF equals PI, PI equals PF. It doesn't matter which order you write it in. Okay, so since I wrote it as PF minus PI, let's write down the expression for the final velocity, final momentum of each one. Since we have two blocks, okay, we'll have to write the momentum of each block separately. So the 1 kg block, its momentum is 1 multiplied by V. And we do not know the sign of V, so let's just put it as V. If V ends up being positive, we know it's going to the right. If it's negative, then we know it's going to the left. Okay, so we have that plus 2 times 5. We know that the 2 kg is moving to the right. Okay, this is all for the end. For the beginning, we have 1 times 10, because it's moving to the right, plus 4 times negative 2, because the 2 kg is moving to the left. Great, we have all our pieces here. Let's apply this. So now we have V plus 10 is equal to 10 minus 8. Great. So V is equal to minus 8 meters per second. So what this says is that in the collision, after the collision rather, the 1 kg block will be moving to the left with a speed of 8 meters per second. It's going to move to the left with a speed of 8 meters per second. Now we could calculate the kinetic energy change, and that will be a fairly straightforward thing. Let's find, you can find the kinetic energy in the beginning, you can find the kinetic energy in the end, and then you could do a ton of things with this situation. You can, we can figure out if each block is going to go and compress some spring. We can figure out how much the spring is going to be compressed, and you can do all kinds of things with it, use energy conservation and other ideas. Okay, so simple application of another inelastic collision problem. But remember this, in order to use this, okay, we have to be given the velocities of at least one of the objects, especially if we do not know that the collision is elastic. Okay, so in general, if you do not know that the collision is elastic, you need to be given some extra information for the final, or some velocity information of the final, to be able to solve the problem. If on the other hand, you've been told that the collision is elastic, then we have a separate set of equations that we can use. Okay, so we'll come to that in a little while. But for now, inelastic collision problem, and we can find the kinetic energies before and after, and see whether what happened in the collision. Alright, so that's it for this one.